Okay, so we will talk about multiple set data structure, like so we have seen the data structure for dynamic set, like a set is where the insertion and deletion is going on. So we have seen heap, we have seen balance tree, red black tree. So these are the data structure we have seen for a dynamic set. Now we want to look at the data structure for multiple set. Data structure for multiple set, not a single set, and these sets are basically disjoint. Okay. So, basically we have a dynamic sets of disjoint sets. So the problem is we have given we have a dynamic collection of disjoint sets, say pairwise, disjoint set collection, and this collection we denote by script S, and these are the set S1, S2, say SR. And this is a multiple set collection, and this is a disjoint set. Pairwise disjoint means if you take any two Si, Sj, they are empty. So, there is no element common to them. So, these sets are and disjoint. So, this is a dynamic collections. So, any point of time any set can join. So, we need to see what are the operation we want to perform on this set, but this collection is a dynamic collection. So, we need to have a data structure for this collection of these disjoint sets, where we want to support few operations. And what are those operations? So, we want to support few operations like so before that, each set, so suppose Si is a set, each set from this script S, each set will have a representative element. So, a element from a set we can choose, and that will be the sort of, this is the representing of this set. So, this is referred as ref of Si. So, ref of Si is an element in say xi, xi will be the ref of Si, where xi belongs to Si. So, we have to choose an element from this is, we can choose any element to be a representative element. So, we have to choose an element from Si which will represent that set. So, that is called representative element of that set, and element from Si is the representative element, So, that means this element is representing the set. Okay. So, this we denote by ref of Si. Okay. And this is this element is distinguished element. So, we can we can this element we should able to tell what is the representative element of this. This is the distinguished element from this set. This is called representative element. Okay. So, given these sets, dynamic sets of sets along with the representative element, we would like to perform few operations. So, we would like to perform few operations like 3 operations. So, this must support this must support 3 operations. What are those? So, first operation is make set. So, we have given a element x, a singleton set. So, we have to make a set which is singleton set. So, we have to add this singleton set in skip test. Skip test is the set of all the, that is the collection, dynamics collection. So, there we have to insert. So, this is sort of make set is sort of insertion. We are creating a set. So, this is kind of insertion operation in the script test. Okay. Or this is sort of what is called we are creating a set. So, once we create a set, then we have to insert this into that dynamic collection of sets. So, this is a singleton set, we are going to add this to S, and then we have to choose the representative element for, because each set is having a representative element. Now, this set is a singleton set. So, it has only one element. So, the obviously rep of this set is basically x, this element itself, because this is having only one element and that is x. So, that is the operation we want to do, and x is not belongs to any other set. Because this is a disjoint collection. So, x should not be a member of any other set, because this is a disjoint collection of sets. Okay. And so, now we want to, so this is the one operation we want to perform. This is the insertion operation or make set operation or create set operation. Now, we want to perform what is called find set. Find set operation. So, find set operation means we have given the element x. So, x must belongs to some of the set, we know that set. So, we want to return that set, we want to say x belongs to this set. So, in order to return the set, we just want to return the representative element of the set. We want to say okay, x is in x belongs to the set whose representative element is this. So, that is the find set operation. We want to find the set where x is belonging. So, for that this operation must give us the representative element of the set. So, this is basically returning the rep of S x where x belongs to S x. Okay. So, we must return the representative element, we must get the representative element of the set. So, basically we need to find the set, this is find set, we need to find the set. So, in order to return the set, we can say we can return the representative element, because representative element is representing the set. Okay. So, this is the operation which is called find the set, and another operation is union. So, we want to merge two set, like this is called union operation, union of so, we have given two element and these two element will be belongs to two set. So, say x is belonging to S x and y is belonging to S y, these two set. Okay. Now, we want to merge these two set, that means we want to do the union of these two set and we want to replace these two set by their union. So, we want to instead of S x S y, we want to delete S x S y and we want to add S x union S y. So, that means we want to just replace these two set S x S y by their union, replace these two set with S x union operation of two sets. Okay. In skip test, this is the collection of set skip test. Okay. So, where these two sets, these two elements are distinct element in Sx and Sy, and then we have to. So, once we replace this, then we have to find the rep of representative element of Sx Sy. So, this we have also have to take care in this union operation. We need to take care of, we need to decide what will be the representative of this union, the new set, which is the union of these two set. Okay. So, let us so this is the problem. So, this is the problem, this is a collection of dynamic collection of sets, disjoint sets, where we must able to perform these three operations. One is insertion operation, we must create a set, we must create a set, that is the make set, then we must find a set, find set means we must, given an x, we must able to return the set where x is belonging. So, in order to return the whole set, we can return the representative element of that set, and the third operation is union, we should able to merge two sets. Okay. And so, the problem is to so, we need to get a data structure, we need to think of a data structure for this dynamic collection of sets. So, we need to think of a, so we need to get a data structure for this collection. For this collection of disjoint sets, where we should able to perform these operations. Okay. So, what data structure we can think of for this collection? So, let us start with simple W connected linked list. Okay. So, let us just think of, so this is first suggestion. So, simple linked list, double linked list, linked list solution. So, we want to store every set in a linked list. So, we want to have linked list for, I mean, so given a set, suppose this is Si, say x1, x2, or this is Sx, x1, x2, say xk, there are k elements say in the set xk. Okay. So, this is the set is unordered collection. In the set there is no ordering of the element, there is no minimum maximum kind of thing. So, it is a unordered collection. So, set is a unordered, there is no ordering in the set. Okay. So, it is an unordered collection. So, given, so we store this element in a doubly linked list. So, we store this element in a doubly linked list. So, how? So, basically we will just have a linked list where we store these elements. So, these elements are x1, x2. So, this is doubly linked list. So, there is a pointer from this node to this node, and there is another pointer from this node to this node. So, this is containing the address of this node, and this field is containing the address of this node. So, like this. So, that is the doubly connected linked list. So, both way it is connected, we can go forward direction as well as we can go to backward direction. Okay. So, this is our Sx, I mean the set Sx, or so we have x3 like this dot 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 So, finally, we have x k if there are k element in the set. We have x k and this is null. This is null and this is also null because this is the first element. Okay. So, we use this to store the set. So, this is our proposed data structure for the set. So, for each of these sets, this is S x. So, for S y also we have another doubly connected linked list. For S z we have another doubly connected list. For each set we can have a we want to have a linked list, doubly connected linked list. So, this is our data structure we are going to propose, and we want to see how fast we can perform those operations like make set, how to insert a set. I mean that means how to create a set, make set, how to find set. So, what is the find operation takes how much time, and then how to do the union. So, those operations we need to. So, this is the proposal. So, we want to for this set S x. So, we store this in a W connected linked list. So, now we want to see the operations how we can perform, like how to perform this set make set operation. And now we need to choose a representative element. So, because this is a data structure we are going to use. So, who is the representative element? So, we want to rep of S x to be the first element. So, this is the first element we are going to choose as a representative element for this set. Okay. So, this is our data structure. Now, you want to see how good data structure is in order to perform those operations like. So, first operation is make set. So, how to make a set? We have given an element x which is not there in any other element because this set has to be disjoint. So, make set means we just create a node with x, that is it. This is null, this is null. So, this is the and rep of this is the first element. Okay. So, this is the make set. So, how much time it will take? This will take theta of 1 time. So, make set will take theta of 1 time. Now, how to find a find set? So, how to find a set? So, suppose so this is so we want to return a set where x is belonging. So, that means we know that S I. So, this is a S I is containing x. So, this is the set say x 1. So, this is W connected and we have dot 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 we have x over here. Then we have this is x k. So, we know this pointer. We know this. So, this is representative of this S I is basically the first node of this x 1. Okay. Now, to find the set we have given an element and that element is say belongs to x I. We do not need to find the position of x I, that is given, that information is given. Somehow we have a pointer to reach there. So, that we are not finding. So, that information is given, somehow we can reach there directly. Okay. So, we are here, we know this S I is containing this x. So, now we need to get the representative element of this set. So, the representative element is the first element. To reach to the first element, what we do? We travel the list backward and we reach to the first element, we check whether this is first element or not, and this is our x 1, we returned x 1 the first element, and that is the find set operation. So, we return the x 1 which is basically rep of x I. So, for that we need to traverse the list from backward way, but this is W connected linked list, there is no issue with that. Okay, so how much time it will take to do that? It will take say linear time. We do not know where is x. So, we go to the x, maybe x is the last element, and if there are, if the size, if the total number of element is n, then in the, I mean this is a linear time operations. Okay. Then how to do the union? Suppose we want to do the union of two sets. So, that is the third operation we want to perform. Okay, so this is the third operation, union of two sets. So, x is belonging to S x and y is belonging to say S y. So, we have given two elements. So, that means we know where these two elements are belonging, they are belonging to two sets S x and S y. Now, we need to replace this S x S y by their union, S x union S y. Okay, so that is the union operation. So, how to do that? So, this is S x, so this is x 1. So, we have some nodes over here, x 2, this is null. So, then so we have dot 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 somewhere S x is here, and we have the last element say dot 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 say x k dot 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 dot. So, this is the S x and we have S y, say we have y 1, we have y 2 dot dot dot. So, somewhere y is here, y is one of the element in this set and the last element is say y l. So, this is null, this is null, this is null, this is null. So, this is the two set S x and S y. Now, we want to perform the union operation on this two set. So, in order to perform the union operation, what we do? We just connect this. So, one set say we just connect this. So, this null. So, we reach to S x. Now, for after that we have to reach to the end of this set. So, then we connect this with this and we know S y, we know y. So, we have to reach to the beginning of this and then we have a pointer to this. So, just we are joining these two W connected linked list. So, and then so this is the union. So, this set is now we replace this set by S x and S y both by S x union S y. This is the merging. So, we are doing this by just connecting the one set with another set with the help of linked list. Just we are adding the pointer of one set to the another set. So, this is basically the union, and so how much time it will take, and what is the now what is the representative element of this? So, representative element is first element. Our new list have length more, it is added the length of y also, but now this is the new W connected list, and what is the rep of this? Rep of this again the first element which is still remain x 1. If we merge this with this, then this could be y 1. So, this we will see how what is the optimize optimal way to merging this. Okay, so, this could be this is the representative element of this. So, now how much time it is taking to do this union? Now, the time taking to do this union is basically because we know the position of this S, but we need to reach to the end of this. Again we know the position of y, we need to go to the beginning of this. So, that will take linear time. So, this union will take linear time operation. So, because we need to traverse the list to for S x we need to go to the end. So, for S y we need to go to the beginning in order to merge these two lists. Okay. So, now this is the this we want to do it in logarithm time. So, we want to do it in log n time instead of n. So, we want to perform this also. So, make set is okay, make set is just a constant time, but other than make set like find set and union are taking logarithm time. So, that we want to discuss how we can achieve this by the logarithm. We will think of whether this balance tree can help us for doing that, and then we will see how we can get the better data structure for this problem. That we will do in the next class. Thank you.